Welcome back for the final part of Module 7, Lesson 2, and as promised, it is your turn to solve a problem. You should be working extra example 4 on your own right now. Go ahead and pause the video and work on it, please. Did you get the right answer? Let's see how I'm going to do this one. Vanessa makes 7 identical flower arrangements. So we know, since you have 7 things that are identical, that we're going to be multiplying 7 times the sum of some stuff or the difference of some stuff. For the table arrangements at a banquet, each arrangement contains some roses and 9 tulips. So I got roses, some number of roses are, plus 9 tulips. And we also know that she uses a total of 147 flowers. So 7 arrangements times the sum of the roses and the 9 tulips is going to equal to 147. And with that, we've already created our equation. So let's see if we find something that matches here. 7 times the sum of R and 9 is equal to 147. That works for me. Now we have to actually solve it and find out how many roses she's going to have in her arrangements. From here, we've got choices. We can use a distributive property, or we can just divide both sides by 7, which is what I'm going to do because I know that 147 is divisible by 7. So I'm going to divide 7 on both sides, with these 7's dividing each other out, leaving the sum of R and 9 is equal to 147 divided by 7, that's going to be 21. And if you think about it, that's not as hard of a problem as it looks like. 7 goes into 14 2 times. 2 times 7 is 14 with nothing left over. Bring down to 7. 7 goes into 7 once, which is 7 with nothing left over. That's where I got my 21 from. Now we're going to undo addition and subtraction by subtracting our 9 from both sides. When we do that, these 9 zero out, leaving R is equal to 21 minus 9. That's going to give us 12 for our final answer. We're going to jump back over here, type your 12 in, and check your answer. And it's correct. She did indeed use 12 roses in each one of her flower arrangements. And now it's time for example 5. In this one, Jamel and his 2 cousins. So how many are we talking about there? 3 people, and they all received the same amount of money to go to a movie. Each boy spent $15, and afterwards the boys all together had $30 left. So let's see how we're going to set that one up. We know that 3 boys went or combined, so we got to set up our equation and can say something like 3 times the amount of money each boy had left to spend is going to equal to 30. From there, we're going to take and define a variable where they said let M equal the money that each boy received, because remember, their folks all gave them money before they went to the movie. And so M minus 15, that's going to be the amount of money each boy has left to spend. And then from there, if you look at an equation, you have 3 times the money their folks gave them minus the $15, that's going to equal a total of 30 when they were all said and done. From there, we get to actually start working on solving our equation. They took the original equation there, and they're going to use the division approach, divide by 3 on both sides. These 3's divided each other out, leaving M minus 15 on the left, and 30 divided by 3, that gave us the 10. From there, we're going to undo addition and subtraction by adding 15 to each side. And when we add 15 to each side, that's going to end up giving us, well, the 15s are going to zero each other out, leaving M on the left. 10 plus 15, that's going to leave me with 25. And check the answers. M equals 25 is the final answer. So how much money did each kid have starting off? Each one of them were given $25 before they went to the movie. From here, of course, you get the opportunity to work one of these on your own. So we're going to skip on to the last piece of work for our assignment here, which is going to be extra example number 5. Go ahead and pause the video and work through this one on your own. So did you get the right answer? Let's take a look at how I'm going to do this problem. I'm going to start off by saying, Chin, he buys 5 bottles of orange juice. So I know it's going to start off with 5 being something important. I'm going to assume, be careful assuming, that 5 is what I'm multiplying everything else by. He has coupons for 65 cents off, so that's going to be minus 0.65, the regular price of each box of juice. Let's see here. I zoomed in too much. There you go. After using the coupons, the total cost was going to equal to $6.20. So what do I have? I have 5 times the cost of each box of juice minus the 65-cent coupon is equal to $6.20, the amount he paid total. Well, they said to use P, so let's go ahead and put a P in right here. And now we want to see, do my equation or my expression match up with what they have? So right there, the very first one, nope, I don't. I got a minus sign, not a plus sign. So scrolling down, 5 times the price minus 65 equals 620. That should be the right one, and it does check. Now we're going to work on solving our problem. I'm going to take and divide both sides by the 5, here and here. These 5s divide each other out, which is going to end up leaving P minus 65 cents is equal to, and then when I do $6.20 divided by 5, well, that's going to end up giving me $1.62. Let's see if I did that right in my head. $6.20 divided by 5. 5 goes into 6 once. Once. Let's make that a little prettier. Once. 1 times 5 is 5. 6 minus 5, that's going to equal to 1. Bring down the 12. 5 goes into 12 2 times. Got a decimal right there. 2 times 5 is 10. Oh, nope, I didn't do it right. Bring down the 2 and the 0. 5 goes into 24 times. 4 times 5 is 20. So that should actually be a 4 right here. From here, we get to take and make that look prettier. Come on. There we go. So we're going to do a 4. And then we're going to add 65 cents to both sides to finish isolating our variable. That's going to zero out, leaving the price of each container of orange juice. Going to give me a 9. That's going to give me a 2, and a 2 was $2.29 before the discount. So jump back over here and put in our $2.29. Check the answer. Uh-oh, did I do bad math adding here? Hold on. I see what I did wrong. This is right here. That number should be a 2, and because that number's a 2, everything else is going to change. So now that's going to give me an 8 and a 1. How about $1.89? Does that sound better to y'all? 1.89. Check our answer, and the answer checks. With that, it's time for you to start doing your homework. Make sure you're showing me big kid algebraic work so I can give you credit for doing it.